Hey everybody, this is Mr. Schaefer, and this video is going to cover the topic of how to graph piecewise functions. And I'd like to just start by reminding you of the definition of what a piecewise defined function is. And that is simply a function that is represented by a combination of equations that each corresponds to a different part of the domain. So we have different pieces, different functions kind of grouped or bracketed together, and where the functions are defined will be based off of what the domain is for each one of those pieces. Each piece gets its own separate domain. So that's kind of the background and definition into what a piecewise function is. What I'd like to do is actually graph one, which maybe looks something like this. We have three different domain restrictions or three different addresses and three different pieces of functions. And it's our job to graph those functions sort of piece by piece and put them on the grid. Here's an example of what a finished product would look like, but I would like to move forward and do an example. In this case, this is example number 4, and kind of talk through how this one would work. So here are the three pieces: 4 minus x squared, 4 minus 2x, and then square root of x minus 2. We'll start with the red circle here. On the domain x is less than 0. So for all numbers where x is less than 0, I'm going to come over here and create a little data table, an x f of x table, or an xy table. And I only want to use inputs that are less than 0 according to the domain restriction that I have. So if I plug in -1, I'll have 4 minus +1, which is going to be 3. Plug in -2. Plug in -3. And then I want to actually include 0 here. Now notice that 0 is not in the domain for the first piece, but I do want to include it simply as an endpoint, sort of a reference point. But to remind myself that I should not color it in or fill it in, I'm drawing this large oval here, and I'm just going to write the words open circle to remind myself that 0, if I include it as an input value, that's fine for reference purposes. In this case, it looks like 0, 4. But when I go to do the graph, I'm going to put an open circle on that 0, 4. Something like that. And then plot your points: -1, 3, -2, 0, -3, -5. And that will go on toward -infinity. So for all numbers, all x numbers less than 0, it looks like we have this half of a parabola. Now let's continue that with my middle piece. Here the domain is all numbers x between 0 and 2. X is greater than or equal to 0 and less than or equal to 2, or 0 is less than x, which is less than 2. And we have equal to bars, so I can actually include those endpoints. So here in this middle table, I have another x f of x table. I have 0, 1, and 2 as my inputs. Plug in 0, we're going to get an output of 4. Plug in 1, we'll get an output of 2. And then plug in 2, and we'll get an output of 0. So 0, 4. Notice 0, 4 can get colored in, so I can come up here and put a little closed circle on 0, 4 now. 1, 2, and then 2, 0. Connect the dots, and there is the linear piece to that piecewise function. Ending here with the square root of x minus 2. So I have one final table here to sketch. And this is valid on all inputs that are greater than 2. So my domain here, x is greater than 2. So let's pick 3, 4, 5. Any number greater than 2 would be okay. I'm going to put 2 down there as well as an endpoint marker, but I'm going to make a note to myself to leave it as an open circle once again. Okay, plug in 3, and we'll get a 1. Plug in 4, we'll get a root 2. Plug in 5, we'll get root 3. And finally plug in a 2, and we'll get a 0. And 2, 0 is already filled in, so I'll just maybe circle that as a reminder that it's a shared point. 2, 0. So 3, 1, and then 4, 4, root 2, so a little bit greater than 1. And then root 3, even greater. And I can kind of start to see the square root function emerging. So there is my sketch. And that's the piecewise function. That's the graph of this entire piecewise function right here. If I were to look at the domain and range of this, it looks like the domain, which is leftmost to rightmost x coordinates, x values, negative infinity all the way to infinity, left to right. Range is low to high, lowest y value and highest y value. Domains are x input values and range is y output values. Same here, negative infinity all the way to infinity since it's always increasing. So kind of a nice domain and range for that piecewise function as shown. So that's how you would graph a piecewise function. And remember that piecewise functions have domain restrictions. Think of them as simply the address of where each piece of your function is going to be defined.